Okay, welcome along to the Year 11 homework #1 solutions with the topics that you can see below here. I'll go through all of the questions, hopefully making it clear what the answers are for the question. So without further ado, let's get into it. The first question says express 56 as a product of its prime factors. So prime factorisation. Now, for this, make a note of your prime numbers. Okay, it's going to be useful for sure. So the first few ones, we've got a 2, 3, 5, 7, 11, 13, so on and so forth. So we can begin with our number, which is 56. And I always say, if you can, divide your number by 2, because 2 is prime. And it's quite an easy one to divide by. And we can divide by 2 here. We can do 2 times by 28 gives you 56. Okay, and 2 is prime, so we can circle it. Now, 28 isn't prime, and again, you've got to divide it by at least one number that is a prime, and you can divide it by 2. So we can go and do 2 times by 14, and 2 is prime, which is good. Again, 14, you've got to split it up with one number being prime, and you can divide it by 2 again. You can go and do 2 times it by 7, and 2 is prime, as you can see, and 7 is also prime, so we can circle both these numbers. Therefore, 56 is the same thing as these numbers here, okay, times 2 together that are circled. So 2 times 2 times 2 times by 7. Okay, literally 2 times 2 is 4, times 2 again is 8, and 8 times 7 gives you 56. Okay, so this is your answer, or you could write it as 2 cubed times by 7. Okay, they mean exactly the same thing, just this one over here. This is your answer in index form. Okay, in index form. But they both mean the same thing. Okay, good. Next question. Same sort of thing again. Again, you want to write your number 525 as a product of its prime factors. Again, your prime numbers, make a note of them, are 2, 3, 5, 7, 11. That should be enough for this. Now your number here, 525, you've got to divide by at least one prime number, and because 525 is odd, you can't divide by 2 here, but you can divide it by 5. You can do 5 and times it by 105, gives you 125. 5 is prime, so you can circle it. Now 105 is not prime, but again you can go and divide it by 5, because 5 is prime, so that's going to be good. And 5 times by 21 gives you 105. Now 21 isn't prime, but you can divide it by 3, which is prime, and 3 times 7 gives you 21, and 7 is also prime, so we can finish here because you can't break down these numbers any further. So simply 525 is going to be equal to, in order, 3 times 5 times 5 times 7, okay, or in index form, you could write it as 3 times 5 squared, timesing it by 7. Okay, they both mean the same thing. They're both correct. Just this one, you've written in index form because you've got powers there. Okay, good. This question, find the lowest common multiple, so the smallest number that 180 and 504 both go into. Now, you could write out your times tables here for 180 and 504, but you're going to be here for a long time, so you've got to use prime factorisation here. Now, 180, again, your prime numbers are 2, 3, 5, 7, 11, so on and so forth. Now 180, we can divide it by 2, because 2 is prime, and 2 times 90 gives you 180. 90, we can do 2 by 45. 2 is prime, 45 is not prime, but we can divide this now by 5, because 5 is prime, and 5 times 9 gives you 45. 9 isn't prime, but 9 is the same thing as 3 times 3, and both of these are prime, and we can stop here. So 180 is the same thing as 1222, so 2 times 2 times 3 times 3, timesing it by 5, okay, and that's good. Now 504, let's break it down. Again, if you can divide it by 2, divide it by 2 because 2 is even and prime. We can do 2 times by 252, okay, 2 is prime, 252, you can go and do 2 times by 126. 2 is prime. 126 divided by 2 again, so 2 times by 63. 63, you can divide it by 3, okay, and times it by 21. And 21, you can go and do 3 times by 7. So there we go. So 504 is the same thing as you've got 3 2, so 2 times 2 times 2 times 3 times 3, timesing it by 7. Now, just to show you a bit of a trick here, if you've got the right kind of Casio calculator, you can actually get it to write your number as a product of prime factors straight away. So to save time and check your answer, you could, if you've got the right Casio calculator, you can type in your number, press the equals button, press shift, and then find it where it says fact, and then it will write your number as a product of prime factors in index form. So 2 cubed, which we've got, 3 squared times by 7. Okay, so if you can do this, it's a good little trick to have in the exam. Now, we're not finished. We want to go and get the lowest common multiple. So let's go and draw in our Venn diagrams now. Okay, so over here and over here. Now the first circle is going to be for my number 180, and the second one is my number 504. Now, what is common to both numbers? We've got a 2 and a 2. They can go in both. Another 2 in both. You've got a 3 and a 3 in both. Another 3 in both. And that's it. The 5 just belongs down to 180, a 2 to 504, and a 7 also to 504. Now, to get the lowest common multiple here, you just times all of your numbers together within the Venn diagram. So we just go and do, to get the LCM, we just times everything together. So it's going to be 5 times 2 times 2 times 3 times 3 times 2 times 7, and that is equal to 2520, and that's my answer. Okay, so the smallest number that 180 and 504 go into is 2520. Okay, next question is this, which I think this one caused a bit of confusion. This one is actually easier because you've got your numbers A and B already written as products of the prime factors. So if you were to kind of times this all out, you would get whatever the number is equal to. But it's already written your numbers as products of prime factors, which is useful. So to find the LCM here, we just go and draw in our Venn diagrams, okay? So first circle and the second circle. And your first number, they just called it A. The second one, they called it B. Now what you could do here to make it a little bit clearer is write this out kind of in long form. So 2 cubed is 2 times 2 times 2. 3 squared, 3 times 3 times 5 times 5 times 11. Now this one, you've got 2 4 times. Okay, you've got timesing it by 3. 5 4 times. Okay, and then we've got timesing it by 13. And then putting your numbers into the diagram. So you've got a 2 and a 2, which is here. A 2 2 in here. 2 2 in here. You now got a 3 and a 3, which goes in here. A 5 and a 5, which goes in here. Another 5, which goes down here. And I believe that is it. Yeah, so now you've got a 3 and 11 that just belong to A. And you've got a 2, a 5, and a 13 that just belong to the number B. So to get the LCM here, and be careful, give your answer as a product of powers, so index form of your prime numbers. Okay, to get the LCM here, we just times everything together again. So everything within here, I'm going to go straight in numerical order. So let's go and do, how many 2s have we got? We've got 1, 2, 3, 4. 4 2s, so that's 2 to the power of 4. We're timesing it by, how many 3s have we got? We've got 1, 2 3s. Okay, so 3 squared. How many 5s have we got? We've got 1, 2, 3, 4 5s. So 5 to the 4. Any 7s? No. Any 11s? Yeah. We've got 1 11, and we've also got 1 13. Okay, so should be 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be good. Okay, and this is my answer. Okay, because my answer is in terms of powers of the prime numbers. I've just times everything here together. Okay, and that's my answer. Good. Question 6. We've got a classic LCM style question, which is this. So you've got a train leaves the eastbound station every 25 minutes and westbound every 45 minutes. They both leave at 8 AM. When they next leave the station together? So for this one, you could use prime factorisation here to find the LCM, but because your numbers are relatively small, I'm going to trust that they're going to meet pretty quickly. So if we go and look at the eastbound train, let's go and do it in green. Okay, so we look at the eastbound train first of all. Every 25 minutes is going to be every 25, so every 25, then 50. It's your 25 times table, and just do quite a few of these. I'm not sure when they will meet, but probably it's going to happen fairly quickly. I hope it does. Okay, so I've just gone up to 350. Okay, that should be plenty, I hope. Otherwise, it might be a bit of a pain. But then we've got the westbound, which is every 45 minutes. Okay, so your 45 times table, which is 45, and then 90. And we'll keep adding 45 to this. 135, and you're just looking for a number where they both meet. We've then got 180, not meeting yet, are we? We've then got 225. Okay, there we go. Good. Right, so we can see here, I can see that they both meet after 225. That's the first time that they meet together. Let's just double check. I've missed I've missed one out. No, that is it. Now, what is 225 minutes in terms of hours and minutes? Because you want to add it on to 8 AM. Now, we know that 1 hour is, of course, equal to 60 minutes. So 6, 12, 8, you can fit 3 60 minutes into this. So you've got 3 hours will take you to 180 minutes. And then 180 to 225, you've got 45 minutes left over. Okay, so 225 minutes is the same thing as 3 hours, 45 minutes. And then add it onto the 8 AM. So go and do 8 AM plus 3 hours and 45 minutes mins. That's going to give you 11:45. Okay, and that should be your answer. So the next time that they meet each other is this 11:45. Okay, good. Moving on. This question. So either it's going to be Pythagoras or trigonometry, because you're given an angle 100% trigonometry. So this is your SOHCAHTOA stuff, and let's label up the triangle. So you've got your angle here, your side opposite the angle. You always go and call it the opposite side, you call it the O side. Okay, and then this side here is your hypotenuse, because it is opposite the right angle. So it's your longest side, it is the hypotenuse. Okay, now this is the adjacent down here, but because it's blank, there's nothing there at all, no information. There's like no X or number or anything. Leave it unlabeled. Okay, now we go to our SOHCAHTOA, and we think, which one of these has got both O and H in it? Well, SO. You've got O and H, which you've got here. So we're using SO, and I would definitely recommend you draw out your triangle for this. Okay, so SO, where that S we know stands for sin of the angle theta, is opposite over hypotenuse. Now we're trying to find X here. That's what you're trying to find, the missing value of X, which is the opposite side. So you can say that O is going to be equal to sine theta times the hypotenuse. So sin of the angle times H. So get the formula down, and then you substitute. So O is X, that's what you're trying to find. So X is equal to sin of the angle, which is 60. So sine 60 times it by the hypotenuse, which is 32. And then you just go and type this into the calculator. Okay, so let's go and do that. Calculator over here. So sine 60, close the bracket, and times it by 32. Okay, and we get this answer here, which as a decimal gives you this. Now, the question is saying give your answer correct to 3 significant figures. Now, if we write the number out in full, you've got like 27.7128, so on and so forth. Now, the third significant figure is your third non-zero number. So that's your first significant figure, that's your second significant figure, this is your third significant figure. And because the 1 is less than 5, you round it down and keep it as a 7. So it's just going to go to 27.7 to 3 significant figures. And it's quite important that we get good at the rounding because you lose marks for inaccuracies there. Okay, but that is it. And I always think like a sanity check, does that make sense? Well, yeah, if this side here is 27.7, it is a bit shorter than the hypotenuse, the longer side, so it seems reasonable to me. So that's good. Okay, on to the next question, which is it Pythagoras? Is it trig? Let's have a look. So we want to work out the size of angle, so definitely trig, RPQ. Now, RPQ, we're looking at the middle part, which is the P part. Okay, so we want to go and find the P angle, which is this one over here. And because we're trying to find it, let's go and call it a missing thing. Let's go and call it X. Okay, and it's definitely trigonometry because you've got an angle, okay, which means it's trig. Now, again, your angle's here, your side opposite the angle is your opposite side, but there's no information there, so leave it blank. We know that your longest side is the hypotenuse, opposite the right angle, so this must be the hypotenuse, and that must be the adjacent. Again, SOHCAHTOA, I'm writing it out just to show you exactly what you should do in the early phase of learning this. Now we're trying to find, sorry, we've got A, we've got H, so it's going to be K. You've got A and H, so we're using K. And again, definitely when you first do this, draw out the equation triangles. It's going to make your life so much easier. So there we go. And we know that a C, okay, stands for cos of the angle, and then A top, H on the bottom. The middle letter always goes on the top of your triangle. Now what you're actually trying to find here, you're trying to find the angle, which is here, which is the angle part of the formula. So you're trying to find this cos theta part. So you say that cos theta is equal to, put your finger over here, it's going to be A divided by H. So the adjacent side over the hypotenuse, okay? And then you put in your values. So cos of the angle theta, well, the angle, I've called it X. So let's just go and put in X for this. Is going to be equal to the adjacent side, A is 17, so 17 over the hypotenuse, which is 25. So there we go. So cos of the angle X is equal to 17, 17 divided by 25, which is, as a decimal, 0.68. And then to go and get the angle here, that's where you have to go and do the cos inverse thing. So cos inverse of 0.68. Okay, and you put this into your calculator. So shift cos and then 0.68, enter it, bam, and then you want to give your answer correct to 1 decimal place. So your first decimal place here is that 1, and the 5 is going to round it up to a 2. So 47.2 degrees. Okay, and that is your answer. Good. Okay, next question. We've got this. Here is a right angled triangle. Work out the length AC. So you want to go and get this length here. Now, because you've been given 2 other lengths and you want to find a third missing length, everything here is a length, so it is going to be Pythagoras. Okay, so this is definitely Pythagoras. So we're trying to find AC. Again, label that missing thing that you're trying to find. Go and call it something like X. Okay, and it's going to be Pythagoras. So A squared plus B squared is equal to C squared, because everything here is to do with a length. So Pythagoras. And we know that opposite the right angle is your longest side, which when you do Pythagoras, you go and call it side C. Your two shorter sides, you go and call A and B in either order, doesn't matter. Don't let these letters here confuse you with the labelling of the triangle. This A, B, C here is just the labelling of the triangle. If it confuses you, just cross it out, okay? It's just labelling the triangle up. Okay, so formula, let's go into it. So we've got A squared. A for me is 39, so 39 squared. Add B squared. B is 70, so 70 squared equals to C squared. I've called C x, so just put it in as x squared. Now 39 squared is equal to whatever that's equal to. So 39 squared gives you 1521. So 1521. Add 70 squared gives you whatever it gives you. 70 squared is equal to 4,900. And that is equal to x squared. Add these parts here together. We're just simplifying up now. So add this to 1521 and we get this. So 6421 is equal to x squared. Now to find x, you've got x squared. You've actually got to go and square root both sides. So x will be equal to the square root of 6421. Okay, so that's now going square root 6421. Enter it. And then to 1 decimal place, we get 80.1 because the 3 will round it down as a 1. So it's going to just be 80.1 to 1 decimal place. And that is my answer. Okay. Good. The key thing here, Pythagoras, because there are no angles involved. It's just all 3 sides. Okay, on to the next questions, and we're getting there. So these ones here, they caused a bit more confusion, but there's no reason why you can't do these here. So let's give this a read. I'm just going to go move the page a little bit over here. Okay, so the diagram below shows a ladder against a wall. So you've got a ladder which is here against a wall, and you've got a right angle down here. Now the ladder stands on a horizontal ground. That just means it's on a flat horizontal ground here. The length of the ladder is 6, which you can see in the diagram. So that ladder is 6. The bottom of the ladder is 2.25 meters from the bottom of the wall. Again, you can see that on the diagram already. A ladder is safe to use when the angle marked Y is about 75 degrees. So when this angle is about 75, it's safe to use. Is the ladder safe to use? Basically, you just want to go and get this angle here and compare it to 75. Okay, so because you've got an angle, right angle triangle, angle, definitely trigonometry. And let's label up the triangle. So we've got our angle here. The side opposite is the opposite side. Because you don't have any information here at all, leave that one blank. This is your hypotenuse opposite the right angle. That's your longest side. So that is your hypotenuse, and this must be the adjacent down here. Okay, that is your adjacent side, A. And again, SOHCAHTOA. Make a note of it. Which one has got both A and H in it? It's going to be K. Okay, you've got A, you've got H, which is this one here. And again, definitely draw out the equation triangle. It just makes your life a lot easier. We know that the C stands for cos of the angle, and we've got A and we've got H over here. Now, what are you trying to find here? You're trying to find the angle part, which is the cos theta part. So the formula is going to be cos theta is equal to, put your finger over this part, and it's going to be A divided by H. So A over H. And then just substitution. So cos of the angle, well, the angle for us, they've called it Y. So just replace it with Y being equal to the adjacent, which is 2.25. So 2.25. We are dividing by the hypotenuse, which is 6. Okay, so cos of the angle Y is equal to, I put it into a bracket just to make it a bit clear. We've got 2.25 divided by 6, which gives you this, which is pretty nasty. Now, oh no, it's not nasty, 0.375. There we go. Now, to go and get the angle here, we've got to go and do cos inverse now. So the angle Y is going to be equal to cos inverse 0.375, which is equal to whatever it's equal to. So We go shift cos inverse 0.375, close that bracket, enter it, and we get this. So 67.975. So let's just go and write this up. 97 dot dot dot. Now this is approximately equal to, so if I zoom out a little bit, get rid of the calculator. Now this is approximately equal to 68 degrees if we just round it to the nearest whole number. Now, is it safe to use? Well, no, because it's not 75 degrees. 68 is quite a long way off 75. So I would say, is that safe to use? No, because 68 is lower than 75. Okay, and that is your answer. But it's just recognizing, right, that the question is just saying get the angle from trigonometry. It's just kind of what scares people is you've kind of got loads of words here with a diagram that's kind of a bit more, but it's just the same thing. You've just got a triangle, which is right angled. You just are looking at this here, and we're just getting this angle, which we've done over here. Last question, I think, is this. ABC is an isosceles triangle. Okay, and we can see that because we've got two angles here that are the same size. And it says work out the area of the triangle. Okay, now what I'm thinking here is, right, always useful to try and get some sort of right angle triangle. Now, if we go and split this triangle in half from A, okay, you're going to be creating two right angle triangles, okay, which is useful. And we also know that to get the area of a triangle, so if we have a right angle triangle like this, okay, bam, bam, and bam, and this is the base and this is the height of a triangle, the area of a triangle is equal to half times base times the height. Okay, you times your lengths together, okay, then you've got to half it because it's half of a rectangle effectively. So this is the formula to get the area of a triangle. Now we know this, so what I can do is, well, I need to get the height of this triangle here, okay, which is where the trigonometry part is going to come into play. So if I go and draw out this triangle here, B to the middle part up to A, and let's just go and do that down here, and let's go and do it in a different color, so like this. There we go. And we know that this angle here is equal to 54. If I've split this length here in half, that must be equal to 6. Now, I want to get the height of the triangle, okay, which is this part here, to use it in my area of a triangle formula. So let's go and call this here x, because I'm trying to find this. And because you're given an angle with a right angle triangle, it is definitely trigonometry. So label up your triangle again. So here's your angle, your side opposite the angle, we call the opposite side. This would be the hypotenuse, but there's nothing there, so leave it blank. And this is the adjacent side. So SOHCAHTOA again. And which one is it going to be? It is going to be TOA, because you've got O and you've got A, O and you've got A. And again, write out the equation triangle that we need. So here we go. We've got T is tan of the angle O, middle part up here, A down here. Now we're trying to find the opposite side here. That's what we're trying to find. So we're trying to find the O part. So O is going to be equal to, cover your finger over this part, and it's going to be tan of the angle times the adjacent side. So tan of the angle times the adjacent. Now O, I've called it x, so it's going to be x being equal to tan of the angle, which we know is 54. So 54, and we're timesing that by the adjacent side, which is equal to 6. Okay, so x is going to be equal to calculator time. Let's go and get it out. So tan 54, tan 54, and we are timesing it by 6, which is going to give you this, and I'm not going to round too early because I'll get rounding issues. So 8 point, let's just go for 258. That should be enough for the time being. So I now know that that this height here, which is this height of the triangle here, is equal to this 8.258. So this is equal to 8.258. So I can now go and use the area of a triangle formula to get the area of one triangle. But because these triangles are both the same, I can just go and then double it. So let's go and do this. So if I now go and draw out my triangle, okay, so we know that this, that's not really neat, is it? Sorry, let's do it again. We've got this, and this. Okay, we know that this length here, okay, this part is equal to 6. We've got a right angle which is here, and the height of this triangle we now know is 8.258. Okay. Now, area of a triangle is half times your base times your height. So we just say we've got half times the base, which is 6, times the height, which is 8.258. Okay, and that's going to be equal to whatever it's equal to. So times 6 times 8.258, and we get 24.774. This is the area of one triangle, this one here, but you've got two of the same triangle. They are congruent, they are identical. So you can just go and take your number and times it by 2, double it, okay, 0.774. If we do this, we get 49.5 if we round it. Okay, 49.5, because your answer is to 3 significant figures. So this will be my answer, okay? And it's going to be, sorry, in centimeters squared. And that's the answer. Okay, so it's just kind of spotting the question, right? If you're given some sort of a triangle, area of a triangle, we know for a right angle triangle, it's half base times the height. So you've got to try and create a right angle here. Once you do that, you unlock the question, okay? And that's it. Hopefully that was useful. So I recorded this quite late at night, so I'm a little bit tired, but hopefully you got something out of it and it was fairly useful. If not, you can always come and see me in the interventions. But thank you for watching and keep up the good work. Well done.